In this section, we will cover the general concepts behind acoustic simulation in Canvas, the available mapping types and their settings, and simulation controls and settings. In addition, we'll configure the studio and workspace views used to support analysis of system performance, and conclude with working with data views. System simulation within Canvas is designed to behave like a real-world PA system, meaning that if a source or component is active, it will appear in the simulation in the same way it would appear in your measurement of the physical system. You control each source using its operation controls within the source list. Here you will find functions such as mute and solo for individual arrays, groups, or loudspeakers. In addition, a global mute control is also available for the complete system. Any processing such as gain, delay, or near-field correction is taken into account in the simulation, so you can be confident that you are seeing an accurate representation of the system's direct field performance. Selecting a component within the Sources tab and choosing the Processing tab within the Component Data Fields section shows you what processing functions are being applied to the selected loudspeaker, pair, or group. Mapping is always displayed in a model view, either 3D system or top view. Data such as magnitude response or phase traces are per measurement point. Measurement points are added to the venue model in either 3D system or top view. Measurement points are used in the same way that you would use a measurement mic position with the physical system. Canvas supports two mapping modes. Dot map is the default mapping type. With the dot mapping, a set of impact points is shown for every 5 degrees on axis within the stated horizontal coverage angle for each enclosure within a line array. This provides a quick visual of aiming and coverage for one or more arrays. For individual point sources, the dot map shows the nominal coverage angle, and the dot map is not used with subwoofers. Dot mapping is automatically recalculated as changes are made to the design. A full coverage map calculates the acoustic arrivals at every field point for the active mapping surfaces within the venue model and displays the resulting sound pressure level map. The default mapping type is an IsoContour map where the color changes for every 3 dB of level change. The mapping resolution is defined within the simulation settings. Maps can be calculated automatically or can be calculated manually as needed. The default is manual calculation, so it does not impact application performance when working on large system designs. It is important to note that any change to a parameter that would invalidate the current map, like changing gain or delay, clears the map and triggers a new calculation when auto recalculate is active. Now, let's talk about mapping controls. In the application toolbar at the top, you have the ability to choose the mapping type among other functions. Dot mapping or full mapping, the Calculate Map control, and the SPL Map Visibility control to show or hide mapping. When a map is being calculated, it is indicated here using a spinning color wheel. On the right side of the screen is where you will find the simulation summary, the SPL scale, and controls to adjust the mapping parameters. The SPL scale is initialized at the first calculation, and the maximum SPL value within the coverage determines the maroon to white transition. You can shift the scale up or down using the plus and minus controls at the bottom of the scale, or you can adjust the range of the scale by entering custom minimum and maximum values. Finally, you can reset the SPL scale by pressing the R control. Expanding the SMPL scale exposes additional mapping settings. The first you will notice are the 1, 3, and 6 buttons below the scale. These are the available options for the IsoContour map, allowing you to select between a 1, 3, or 6 dB change between each color segment. Clicking the active selection a second time will turn off the IsoContour mapping so that a gradient map is used. The next group of controls determine the stimulus applied to the system, the type of map data that is displayed, and the SPL weighting scale that is currently being applied. Available controls in this section are Input Spectrum, where you can choose pink noise, music, or program, bandwidth, center frequency, and the SPL weighting scale. The complete set of mapping and simulation settings are accessible via either application settings, by clicking once on the simulation summary panel, or by using the keyboard shortcut G. Additional simulation settings include temperature and humidity parameters, drive level, which simulates console output level to assess available system headroom. For example, setting drive level to -6 dBu updates the headroom meters accordingly. Auto recalculate on or off. And mapping resolution, which defines the distance between sample points. The default is medium, which corresponds to 2 meters, or 6.6 feet. Additional selections are low, 3 meters, or roughly 10 feet, and high, which corresponds to 1 meter, or 3.28 feet. Canvas offers additional color maps that can be used for mapping. The default is Jet, which is the most commonly used color palette for engineering applications. It should be noted that simulation settings are saved with the project file. This ensures consistent results when reopening a file or sharing it with another Canvas user. Now, let's look at studio views within Canvas. Canvas supports the ability to display up to 3 view panes simultaneously, and each view pane may contain a different model or data view. You can use the view pane control at the bottom of the application to cycle through 1, 2, or 3 view panes, or use the keyboard shortcut, Control, or Command, +1, 2, or 3. In addition, you can customize the setup to match your individual workflow preferences. For example, you may prefer a 2-pane view showing the 3D model alongside magnitude data. This can then be saved as a saved studio view that can be recalled and reused later. Included with Canvas are a number of predefined studio views that match the typical workflow of system designers. Any custom views that are created are stored with the application so that they are available for use with all projects. Data views are used for detailed analysis of one or more measurement points within the venue model. Measurement points are added within either the 3D system or top views, and once added are accessible within the measurement tab in the multipurpose panel. For those data views that rely upon a measurement point, including phase, time arrival, and magnitude, you can select which measurement point is being used for the analysis by selecting it in either the 3D system or top view from the list within the measurement tab, or by using the measurement point selection within the data view itself. Some data views allow you to compare multiple measurement points simultaneously. Magnitude over distance utilizes measurement lines. SPL over distance displays on-axis SPL versus distance from a selected source. In the event you have multiple measurement lines within a project, you can select the measurement line of interest from the top view, from the list within the measurement tab, or using the measurement line selection within the data view itself. Measurement lines include a sample density option of low, medium, or high. The sample density setting determines where along the measurement line a sample point will be placed. We will cover the data views in more detail in the calibration workflow module. You have now become familiar with how Canvas simulation behaves relative to a real system, using dot map and full map to visualize coverage, configuration and use of simulation controls and settings, arranging studio views to support your workflow, saving and recalling custom studio views for future projects, and the basics of working with data views within Canvas.